Good morning to Dr. Anati. I'm Muhammad Nasir Arakama, and today I'm going to present about the types of magma, lava, and volcanic disaster. The content of my presentation today is what is magma or lava, types of magma, magma's temperature, magma's viscosity, gases in magma, how magma is formed, volcanic eruption, effusive eruption, volcanic explosive eruption, and volcanic disaster. Before we start, let's take a glance at magma. Magma can be differentiated according to their mineral composition, and the temperature of magma is quite difficult to measure due to the danger. However, the lab measurement and the limited field observation can indicate the eruption temperature of various magmas. The viscosity of this magma is depending primarily on the composition of the magmas, which is the content of silicon dioxide and the temperature. Almost all magmas contain gases or dissolved gases. Okay, let's continue. What is magma? Magma is extremely hot liquid and semi-liquid rock located under the Earth's surface that contains small amount of dissolved gases. Lava, on the other hand, is a magma that reaches the Earth's surface through a volcano vent. Types of magma can be separated into basaltic magma, which contains the lowest out of the three, the lowest amount of silicon dioxide. However, it is high in iron, magnesium, and calcium, while having low content in potassium and sodium. Moving on is andesitic magma. It has the average amount of silicon dioxide among the three. It is intermediate in iron, magnesium, calcium, potassium, and sodium. For rhyolitic magma, it has the highest content of silicon dioxide among the three. However, it has low in iron, magnesium, and calcium, and high in potassium and sodium. The ranging temperature for basaltic magma is 1000 to 1200 degrees Celsius. For andesitic magma is around 800 to 1000 degrees Celsius. For rhyolitic magma is 650 to 800 degrees Celsius. Nearly all magmas has gas dissolved in their liquids at the depths of the Earth, but the gas is separated into a distinct vapor as pressure decreases as magma rises towards the Earth's surface. This gives magma their explosive character because the volume of the gas expands as pressure is reduced. The gases in magma are mostly water vapor and little quantity of carbon dioxide with minor amounts of sulfur and chlorine as well as fluorine. How magma is formed? Magma is formed by melting the mantle or the crust in a variety of tectonic settings, including subduction zones, continental ridge zones, mid-ocean ridges, and hotspots on Earth. Mantle and crustal melts are thought to migrate upwards through the crustal and be stored in magma chambers or transcrustal crystal rich mass zones. During this magma stored, the fractional crystallization, contamination with crustal melts, and magma mixing, as well as degassing, can all change the compositions of the magma. Moving on is volcanic eruptions. Magmas that form deep into Earth has a tendency to rise because they are less dense than the solid rocks that's surrounding them. As they ascend, they may reach a depth of the pressure which the dissolved gas can no longer maintain in liquid state in the magma. And the gas separates into two phases, which is water, liquid, and gases, or water vapor, or vapor. Okay. When the gas bubbles form, it will also continue to grow in size as pressure reduces and more of the gases coming out from the liquid state. In other words, the gas bubbles are expanding. Next, we're moving on. For effusive eruption, if the magma's liquid component has a low viscosity, the gas can expand quite easily. When the magma reaches the Earth's surface, the gas bubbles simply burst and the gas expands into the atmospheric pressure. And this will result in non-explosive eruption and as well as lava flows. For explosive eruption, on the other hand, when the magma's liquid has high viscosity, the gas will unable to expand freely, causing the pressure to build up inside the gas bubbles. The gas bubbles inside the magma will have high pressure when it reaches the surface, causing them to rupture explosively when it hits air pressure. This will result a large scale of volcanic eruptions. Moving on is volcanic disaster. In 1991, if you can see in this picture, it is the eruption of Mount Pinatubo in Luzon, Philippines. Okay. As a volcano erupts, massive amounts of extremely hot gases, boulders, ashes, and molten rock can be ejected. This is flung into the air, typically cascading down the mountainside. Lava or pyroclastic flows are formed when molten rock streams down the mountain. When a volcano erupts, any building and constructions in the region will be destroyed or damaged. Homes are frequently destroyed by hot ashes dripping like rain and everything below it. And in addition to the flow of extreme hot lava mud. Volcanic eruptions, especially explosive ones, are very dynamic phenomena. This behavior of eruptions will continue to change throughout the course of eruptions. This will make it very difficult to classify volcanic eruptions. Nevertheless, they can be classified according to the principle of the behavior that they exhibit. An important point to remember, however, this is that the given eruptions of the type of eruption may change several times. The first type of eruptions we have here is Hawaiian eruption. These are basaltic magmas outbursts with low viscosity. A fire fountain is created by the gas discharge, which shoots incandescent lava up to 1 kilometer above the vent. When the lava reaches the surface, it is still molten and flows down the hill as a lava flow. For Strombolian eruptions, the vent produces different blasts of basaltic to andesitic magma during these eruptions. Strombolian eruptions are characterized by low elevations, eruption columns, and pyroclastic fault deposits, and they are considered slightly explosive eruption. For Plinian, these eruptions are caused by long-term ejection of andesitic to rhyolitic magma in columns that can reach 45 kilometers above the vent. Eruptions column produce widespread fault deposits that thin down as they get further away from the vent, and they can collapse, resulting in pyroclastic flows and surge. For peritic, it is when a magma collides with shallow groundwater, then the groundwater will flashes to steam. This, which will eject explosively along the exiting rock fragments. However, in this condition, there are no new magmas that reaches the surface. These eruptions may result in surge deposits. That's all from me. Thank you.